Hello everyone. This entry level course on embedded system is suitable for typical college students who are at their undergrad level and who are aspiring to learn embedded system in a very formal approach. Let's get started. So we are Embedded Beacon. You can follow us for more high quality embedded contents. So the course objective is very straightforward. So in this course, we aim to clarify and identify some of the uses of embedded system in various domain. When I say various domain, that includes auto, avionics, medical, consumer electronics, and so on. And also we aim to compare the various embedded system and its software architecture across these domains. And we also want to compare some of the various real world embedded software stack that is used in the production grade development. And we also want to highlight what is the significance of going to the such embedded software stack. So that's the course objective. Let's get started with the formal definition of embedded system. So what is an embedded system? We will try to define the embedded system through various literature. So you will find different kind of definitions about embedded system. So this is one of our version where embedded system is a specialized combination of hardware and software designed to perform a dedicated function. So the key word here is the dedicated function. Embedded system is meant to perform a dedicated function. So you can think like a computer which is made to perform only one task or a dedicated task. So it contains two pieces, and hardware and a software that is running onto it. That is why it is called as embedded system. So there is a software that is embedded into the hardware, so which makes it programmable as well as which does some dedicated functions. So this embedded system also can be part of a larger system, and these systems are usually tailored to execute a specific task based on some process inputs, and it also generate some pre-programmed and predetermined outputs. And these embedded systems are completely driven with the software, as I told. So these are entirely programmable. So which means you can alter the characteristics or alter the functionality, or you can alter the need, or you can do some alteration with respect to the functionality. That's what we mean by programmable. And ideally it should utilize very little memory and should operate with a low power. Yeah. So here are few important attributes of embedded system. So as I told already, the embedded system should have a dedicated functionality. It can be a separate system or it can be integrated with a larger system. Moreover, it has to do certain operations in real time. When I say certain operations in real time, let's say if the door has to be opened within 20 milliseconds, it has to be opened within 20 milliseconds. If you want certain operation should be happening every 5 seconds, then those operations should happen every 5 seconds. So we cannot make or we cannot afford to have a plus or minus delta here. So that is what I mean by real-time operation. Then it comes with a very serious resource constraint. When I say resource constraint, in terms of its uh, processing capability, its memory capability, and most of the time it would be programmable, and it has to have very optimized power efficiency. Then it is containing a specific, or it will work in a specific operating environment only, and it is completely driven by the software that is embedded onto it. Then it can interact, or it will interact with various sensors which acts like an input device, and it controls various actuators which acts like outputs of your embedded system. And it should be completely reliable and stable, and it should be, depending on the system, it might should fit in a wall clock or should fit in a pocket. It should come in a compact size with a neat form factor, and it should have communication capabilities depending on its application. So these are some of the very common attributes of embedded systems. So to highlight further the key characteristics of embedded system, the embedded system should contain a minimalistic hardware, which means you cannot afford to have a very powerful PC or a very powerful computer or a processor in your embedded system. So you cannot able to afford that. It comes with a minimalistic hardware because the objective of this system itself is to create a, a very minimal operation, or it is designed to do a dedicated functionality. Then so it should operate with a very less memory as well as with very less power. Most of the time, these devices, you know very well, these are battery driven devices. So we cannot able to think of driving it with unlimited power. So it has to operate with very minimal power, and also it has some real time constraints. So the software should always meet the timing criteria, and it should guarantee the timing requirement, and it should be programmable, yes, and it has to meet some of the stringent standards that is imposed uh, based on the nature of the application. So let's say if it is automotive, the whole embedded system has to meet several automotive standards. If it is medical, it has to meet all the medical safety standards. So depending on in which industry it is applied, it has to meet all the stringent standards imposed by that particular industry. So how are these systems are different from a general computing system? So you can imagine that I have a computer which can able to do certain processing, and I have mobile phones that comes with dedicated processors, GPUs, can able to run a lot of application and contains rich sensors, and I can do enough operations. So how embedded systems are different from a general purpose computing system? So the very first application, our very first um, difference I would say is the embedded system are purely for dedicated application. So it is a focused application based device. So if you consider a dedicated device like a washing machine, or uh, an, a device that you connect to the internet, does only a functionality of monitoring a camera that is fit onto the gate. So you can think of a system, an electronic system or a programmable computer, but that is doing a dedicated task. That is what we mean by embedded system. Then it is completely for a specialized functionality, and it will have resource constraints in terms of computing capability, in terms of memory, and it has to perform real-time operation. And the cost consideration is also very important. It has to be a low cost device because it's a system that is manufactured and that has doing only a limited functionality. So the functionality and the cost should be matchable. Then most of the time it will have an user interface, because as a user you need to know what are the settings that you do. It should have some input, it should have some control. So most of the time it will have a minimalist user interface, and depending on its application, the form factor would be coming in a different size. So it could be packaged, and it can be part of a larger system, or it can be part of uh, this itself can be a small system where it fits into the place where it has to do. So these are the key differences between a general purpose computing device or computing system with embedded system. So with this, I'm just closing this short lecture on introducing embedded system. So keep watching us. We will give more